Until I got to Mr. Kinney's class. No, y'all didn't like math. You liked not thinking.
No, it was fun.
I love math. I know.
It was fun last year, yeah, that year of COVID when we really didn't have to learn much because.
Who did? Miss Boyd had us talking like
That's a lie. Bullshit.
my class, she had Miss Boyd had us talking like
But you liked math. No. So let's do that. Hey, listen. Hold on. Say that what you just said. It was what? It was easier. We like things that are easy. Hold on.
It wasn't the same for everybody.
Okay? It was easier overall. Look, guys. No. Because here's the thing. No, I'm not acting like you're advanced. I'm acting like we're sitting here, we're saying, hey, Mr. Kinney, I'll never have to use this again. Cool. If you believe that, I hate that for you. But what I will say you will always have to use is your ability to think. We don't like the fact that I'm challenging you to think more. That's what it comes down to.
That's not our point of view.
Say again?
I don't think that's our point of view.
You
see it.
I agree that's not your point of view, but I'm telling you, because I see it consistently, you want me to tell you exactly what to know and what to think and what to do, and that's it, so that you can regurgitate that information for a quiz or a test. That's easy. That's what you want.
No, that's
I'm not using this. When I know my future, that's what I remember.
How it make text?
Stop. My job. Stop and listen. Stop and listen. Stop trying to argue and start trying to actually hear what I'm saying. First off, I teach geometry, not anything that would have to do with taxes. So there's this weird thing. Honestly, you don't need to worry about taxes too much because there's H&R Block out there. There's TurboTax. I don't know anything about the tax code because you need to know about the tax code in order to do taxes, not math. But you can put all your information into an online system and it does it for you. So stop worrying about taxes, start worrying about this math. Now don't argue and listen, don't argue and listen. Don't argue and listen. Stop.
You're arguing.
Once again, Ari, what I need you to understand, what I'm trying to tell you is that you are correct, or not correct, but you may not think you ever need this content. So then what would be the point of me lecturing to you and telling you information that you will never need again?
there is no point.
There is no point in that. My point is that you need to learn how to think and how to analyze a situation and say, hey, this is what I see happening. And that is why this is tougher, because I'm asking you to think instead of me directly lecturing to you and then you just doing the same problems over and over again. That system is easier. I'm not asking you to be advanced, I'm asking you to think. And I know that that's uncomfortable. But I promise you, it's better for you long term. And I know that's not your perspective, but I am telling you, after 2 degrees in the subject of teaching math education and consistently doing research, Gabe, on how to prepare you better for college, and having been successful in college, this is what you need, not me just lecturing to you. This is what you need. Okay? So, moving beyond that, because we're not trying to argue with Mr. Kinney, we're trying to learn something and be successful.
This is a good argument, though.
It's not.
I would love to argue this case. This deserves to be in court.
I took regular.
Okay, when you talk back to a statement that I said, that's arguing. This is arguing. If you want to ask a question, look.
I'm allowed to speak my opinion on something. My parents taught me to never silence myself. If I have something to say, I want to say it. I'm sorry, but that's just how I was raised.
The difference is how you present it. I'm not telling you to silence yourself, because I would never tell a student to silence themselves. But if you want to ask a question that is different than stating your opinion as fact without the evidence, you can ask a question and then we can discuss it.
And you be open to listen to us.
What do you think we're doing right now?
That's what I'm saying. You being open.
Oh, you are saying I am open to listen. Right. I am. I will have reasons that I don't do what I do, but why are you talking over the time I'm talking again? This is what's aggravating.
But y'all was talking to.
This why he get angry.
But pay attention. It's not bad information. You're still talking over the whole class discussion. Okay. But again, I want you to understand, it is not the issue that you have an opinion or that you want to share your opinion, it's how you do it. I am always willing to listen to your opinion, but if you need to share your opinion, you one, don't talk over me about it, because that's disrespectful. You ask a question, and I'm more than happy to have that conversation. Does that make sense? We go with that idea. Okay. Now, looking again at the table, please notice, once again, what is the scale factor
2.5.
supposed to be? 2.5. That being said, what is the length that you should have for TR?
5 U.
TR.
5
5. So on your table, TR is 5. What is T prime, R prime?
12.5.
Have you fixed this yet,
Now.
Austin?
Oh no, it was right.
No, it was definitely not right when I looked at it.
You ain't seen it right.
Okay. You fixed it afterwards? Because it definitely said 5 units. Okay.
Yeah.
So, what is the next question about on that sheet of paper? The angle measure, which one? Gabe, what's the angle measure we're asking about on the table? See, this is why you pay attention.
No, I know what you're talking about.
Okay, so the measure of angle y is 22.6. Claire, what is the measure of y prime? 22.6. Alright. Tyson? What's the next one? 12? Are we looking at, what is it? RY? So the length of RY is 12 units. Right? Gabe, what is R prime, Y prime? 30. And then I think it asks about the perimeter, which, notice we have to go to the next page for perimeter. But I'm going to say here for now, the perimeter for TRY was 30 units. And then TY, not for perimeter. Oh, is area before perimeter?
Yeah.
My bad. What's the perimeter for T prime, R prime, Y prime? 75? Why are we talking over the whole class discussion? We're supposed to be paying attention. So, area of TRY. 30 units as well. And then the area for T prime, R prime. Oh. So, does anyone know what that 2 is called? Is to the second power, but we unit squared. Area is always a unit squared. The reason why is the way we calculate area is by splitting it up into what?
2 sections.
Waffle.
Yo, what would we call that shape?
A square
Oh,
unit.
it's square units.
Period.
That's why it's called a unit squared. Okay? So area is measured in those square units. Anton, you paying attention to that statement?
Yes, sir.
Okay. So what is the area of T prime, R prime, Y prime? 188
Unit. Square.
units squared. Okay. So I want to ask an important question here before we move on to the idea of congruent. How in the world did we get 75 from 30? No idea? Say again?
2.5.
What about 2.5? Oh wait, so you're saying I should have taken, if I take 30 and I multiply it by the scale factor of 2.5, I get 75?
Yes.
I assume so.
Let's check it. Pick up your calculator, do 30 times 2.5. Do I get that 75?
Yes, we get 75.
Don't forget, you can hit the little calculator symbol on the left. Hit it one more time. There you go. So, yes sir. Yeah. So please notice, if you can't, hopefully you can see this, but on the calculator emulator, if you hit this little if you hit this symbol, this little calculator symbol, it'll bring up what's called a scratch pad. Yo, seriously? I'm trying to give you information to help you on these calculators. When you go to the scratch pad, it'll either bring you to the graph, or you hit it again, it brings you to a calculator. Graph, calculator, and literally all you have to do to get away from the scratch pad is hit what?
Escape.
Escape. Okay? So come back to it. So 30 times 2.5, is that 75? Yes? Hey, how did we get this 12.5 here?
5 times 2.5.
5 times 2.5? Okay, so for that, to get our image, we are multiplying by the what again?
Scale factor.
Scale factor, right? And how could we confirm that that is the correct scale factor?
Because we multiplied it.
Well, you could multiply to check it, but also remember how to
Ratio.
calculate a scale factor.
Ratio.
A ratio.
The perimeter.
What do I get when I do 75 divided by 30? That ratio.
2.5.
You get 2.5, right? So it's important to notice how these scale factors and these ratios are all connected. Now, the next question is one of the most important things here. Number 2 says two figures are congruent if they have the same size and same shape. Is triangle TRY congruent to triangle T prime, R prime, Y prime after a dilation?
No.
No.
Why not?
Because the side lengths, the perimeter, the area, the angle measures change.
The size lengths,
Side,
Angle
side
measures.
length, sorry.
Angle measures.
area. and-
Ooh, that's a good question. Do the angle measures change?
Oh,
No, the angle measures are preserved.
Oh, so the angle measures were preserved, but nothing else was?
No, everything
Ah.
besides the angle.
So the side lengths, perimeter,
Area.
and area
aren't the same.
changed, right? Did the shape, did the general shape stay the same?
Yes.
Yes.
Ah, so the side lengths, perimeter, and area changed even though the shape. Now, I want to point this out. Some of us already answered this question. So do you have to rewrite all of this?
No.
No. Check to see if you got all of those ideas. If you got all those ideas, cool, you're good. If you need to add an extra detail, add the extra detail. Kyson, can I help you in game?
I was trying to look for it, right? You need one.
Stop. So, the side lengths, perimeter, and area changed even though the shape was the same. And you could even add the detail that some people noticed about the angles. The angles also were what?
Preserved.
Preserved. There we go.
Ow.
It says change. The area changed. Changed. The side lengths, perimeter, and area changed even though the shape was the same. Alright. Now, I need y'all to pay attention to this. Number 3. A lot of us were stressing about it when all you had to do was read it. No, it's not too much. You expect too little out of yourself. That's consistently the issue, is we expect too little out of ourselves. Change the pre-image of the triangle by dragging one of its vertices. That's the main thing. All I'm asking you to do is to take the pre-image and drag the vertex. Okay? Observe the changes in the dilation image, especially paying attention to the what? Angles and side lengths. Okay? There's some other information there in case you're struggling to get it to work, but I want you to notice, should I be looking at 1.2 or 1.3?
1.2. It don't matter.
It does a little bit.
Oh, well, yeah.
1.2.
Why 1.2?
Because that's where you have the stretcher thing.
Notice I asked you to look at what two things closely?
The vertex.
The change in
The side lengths and the
area. I mean,
Not area.
The side lengths.
Angles.
The,
angles.
yeah.
You remember your, literally guys, just read, and that's what Gabe did, and I will commend him on that. He did not just make, he didn't make it this hard thing, he just looked at the paper and looked at the directions. You move the vertex, but I wanted you to look at side lengths and angles. So, notice how I just grab a point, I start moving it around. And I want you to look at it. Just stop for a second and look. So we still have side lengths that are different, but look at the angles. Are the angles different?
Yes. Yes.
No.
Not at all.
Not at all. T and T prime are 76.
Oh.
R and R prime are both what?
The
The
same.
same.
45. There we go. So let's continue to move Y around. Is this still true that the angles are still the same?
Yes.
Yes.
Oh. That might be important. See, this is all I'm asking you to do is to move stuff around and observe what is different, what is the same. Anyone want to guess what the ratio 20 to 8 is going to be? Say it again.
2.5.
2.5? I mean, that is my scale factor, isn't it?
Yes.
But again, my angles, are they staying the same between the image and the pre-image?
Yeah.
Okay, let's continue to work on number 3 through number 5. Hopefully we shouldn't take too long, so we can get to 1.4. Alright, let's get to work. What's your confusion?
Site.
Okay. Come on, Ren. Come on, Kelsey. Kelsey.
I need to get this trash out of the bike.
Good.
Come on, Gabe.
Oh, you don't?
You smart kid.
I know, right?
They don't really know. So what did we learn earlier doing all of this stuff? So what did we just talk about when we talked about number 3? This would help you with number 4. Pay attention to that at all? Don't figure out. Does anyone remember what we just talked about with number 3? About when we moved the vertex around? Did the scale factors stay the same?
What did you do?
Like when we look at the ratio of the sides?
Read the directions.
Well, before we do that, let's just go on 1.2.
Go back, friend.
So, what I want to point out first is, what I was asking y'all to do on 1.3 is pay attention to the
Get rid of them.
to the side lines. Look at your angles. Are they the same or different?
Or cap.
The angles stay the same. What about now? Alright, I just moved the vertex around. The angle, so T and T prime have the same angle measure. Whereas like these still have different side lengths because there's that scale factor, right? So now all I'm asking you to do is instead of moving the vertex, move this point, the dilation. Look at the angle measure. Look at the side lengths. What's happening?
Wrong.
I'm following that already. It said take the black point on the inside and move it around.
It gives you the directions of, you should know what an isometry is, but what did you already
It
know
says
for
move
number 4?
this point around. Does turn or count earlier?
I said, no,
I mean, that's the same.
Oh, maybe.
What's funny? It's not.
Alright, we did to work.
See, it's
Whoever's throwing, breaking crayons and throwing them around the room, you're really cool, congratulations. But there's this weird thing where if you don't learn the math, you don't learn the math. It's gonna suck for you. And you have to be back in here next semester. Not you.
Not me.
You might have said that.
Wait, so I'm not gonna.
I'm not just gonna pass you, you gotta earn it.
Wait, I'm not gonna be in this class next.
Next semester?
It's a regular
But next year I will be, right?
It's a regular class.
Yeah.
I signed for a regular class.
It's really
Not no advanced, no algebra.
It's not advanced, but
No, it's not.
I had algebra 1 or something like that last year. Algebra is.
I failed math my whole life. It was a C and high. You got me an L.
No, algebra.
I don't have you anywhere. You chose not to put in the effort, which is why your grade is where it is. That does.
Because you can.
Okay, but let's get to work. Come on, I gotta go check in on other
Okay,
groups.
yes, I did this and
Move the point around.
So everything stayed the same? Okay.
I have.
I agree with you. I don't disagree. So like, so the angles always stay the same? Right? So we look over here, they're the same. If you look at the ratio of the side lengths, it's still gonna be the scale factor. So does that confirm or challenge what you learned before?
It confirms it. Wait.
Why does he have your sheet?
Oh, because he had to write down. He was
It's right there when I literally went over these things.
That's what
Number 3, I said, move it. How to find these side lengths in the metric area.
I wonder where my phone is.
When you dilate, is that pre-image congruent to the image, or is the image congruent to the pre-image? What did you say for number 2? Or, yeah, number 2. You say they were congruent? So they're not congruent. Is it an isometry?
Oh no.
That ain't what it is.
Right? An isometry means that the image is always congruent. It's always congruent. What it was.
You crazy joke. Never mad. That's how you
What's your question?
That hurt.
So, I mean, what have we learned in the past?
No.
That when you dilate it, what happens to our angle measure? Well, T and T prime were the same, weren't they? R and R prime were the same, weren't they? So then when you dilate, what happens to the side lengths? Were those affected?
No, you're not.
So like, if I click over here, you're telling me the side lengths are exactly the same right here? No? Ratio. Right, it's got that, multiplied by that scale. Even when I move that down to point right here, is it still being multiplied by the scale? So was that challenging or confirming?
Okay, so now I'm saying.
The question is, does it,
Can I have my baby back so I can
going around, does this confirm or challenge what you've already done? Hey, ladies and gentlemen, I need y'all to go ahead and look at number 5.
Okay.
Go ahead and look at number 5, which should be well past 3 and 4.
And I something I will.
I couldn't. Everybody else says like
It says
I need some backup just in case. I think I'm backup.
Here's the vertex. Oh, there's one. Point R is the vertex, right?
Say all right.
Bro, 5, 6, like
Bro, I was just going to. Bro, I swear to God. You remember me?
Oh yeah, I thought something else.
yeah.
I did say that.
I mean, he may say that, but like, come on.
I want to throw this
But like, answer the question. Oh yeah, Mr. King. Huh? Dude, we're about to have a whole class discussion about the important ideas. You need to be here for that discussion. Are we done through number 5?
Moving.
Michael, do you love it?
There's not a single word in number 5 that we have not covered. You can continue to make fun of me, or you can try to learn.
What? What do you mean when?
You're telling me that the image and the pre-image have the same side lengths?
I think I'll wait till
And then I went back.
Number 5.
Woke up and was
Yes, the same side lengths, area, and
That's
perimeter.
what I'm talking about because we used to wake up. I'm still
Because they are congruent. But if you have a dilation, your scale factor is something other than 1.
I like this.
And what is an isometry?
I wouldn't sleep at 12.
It's defined on the sheet.
I didn't even follow.
It's not
Go,
all
gotta
four.
go, gotta go, gotta go.
That's the issue. What does it say an isometry is on that sheet?
But
of
for
paper?
real, ain't you right?
She is not saying.
So the image is congruent to the pre-image every single time. Are you telling me that that image is always congruent to the pre-image?
Thank you.
I didn't say can it be, I said it is always. The shard, stop arguing.
Number
Listen,
five.
is that, if you tell me
What
that,
y'all put number five?
I said
That's you.
No, what's that?
so then is it an isometry?
Anyway. No, I'm not, bro.
Good.
Shut that mouth.
It is true for both. In enlargements and
No, the image and pre-image has no the same.
They're not
That's
congruent.
Yeah, they're
They don't match. They're not congruent.
Measurement.
They don't have the same measurement.
Thank you, thank you, thank you. I need everyone's attention on this. And I also, again, need to say, and like, I'm just tired and weary at this point, but I need to remind you, before I released you to work in your groups, what did I do?
Tell us what to do.
Explain what?
Number
Number 3, I clearly and explicitly went through what to do on number 3, which is the same thing to do on number 4. I need you to pay attention to directions. I cannot emphasize that enough. Looking here, we moved these things around, right? I can take any of the points, but I take point T, right? I move it around. And what is the big thing that we want to notice about the angle measures? The angle measures stay the same. So the angle measures in the pre-image and the angle measures in the image are what? Congruent. You've got to note that. The angle measures in the pre-image and image are congruent. There is no other way to say it. That is an important thing to notice. Yeah, once again, I'm teaching. I'm providing the direct instruction that you need. Kyson, what do you need? Bro, there are pencils up here. Come get one. So, this is a good question from Ari. Does the image change when you change the pre-image? Yes, 100%. But even when the image changed, the angle measures in the pre-image and image were always what?
The same.
Congruent, right?
Congruent.
And that's what I want you to notice. We're able with these graphing calculators to look at lots of pre-images and images all at the same time. And every pre-image and every image that you looked at, those angle measures were what?
Congruent.
Congruent.
That is an important thing to notice. That is why graphing calculators are huge and are important for your learning. Now, I also want to point out, so I'm going to quickly move this around again a little bit. Right? So I can move this point T somewhere else. No, come back. No, I don't want multi-set. Right? I can move T all the way over to here. Are the angle measures for the pre-image and image still congruent?
Yes.
Yes. But look at your side lengths. Are those congruent?
No.
No. What are the side lengths?
7 point. Oh no, 6.7.
Man, those are very different numbers. Does anyone know how we get those numbers?
No.
The ratio. Okay. Does anyone know what we call something that has the same ratio throughout? It's a P word that you learned in middle school.
Perpendicular. No.
The side lengths,
What did it start with?
a P.
What's the
Side
second letter?
lengths,
What's the second letter?
an R. Side lengths and perimeter
Don't
are
say it. Hurry.
always
Pretty.
What?
Pretty.
Pretty.
Produce.
Propose.
Property.
Property.
Proportional.
Proportionate.
they're proportional.
Yeah.
And when I say that they are proportional, that means that they maintain the same ratio, which is the
The same.
The s-
Ratio scale.
scale factor, right? The side lengths and the perimeter are always proportional. The image and pre-image have the same ratio. Guys, we still have 3 minutes. Stop packing, take some notes. And pre-image have the same ratio, the scale factor. When, for those of us who moved that point of dilation, that black point, did that challenge or confirm what we saw in number 3?
Yes.
It challenged it?
No.
Did you make that up? You're not sure? I'll come back to this in a second. Look, here's my point of dilation. Look at your angle measures. Are the angle measures still congruent?
Yes.
Are the side lengths still
It
proportional?
confirms.
Uh-huh.
Good afternoon, Hillcrest. If you're interested in participating in this year's Gospel Book Team, please visit the advisor, Mr. Patton, in the library. Tap and Jab pictures will be taken on Wednesday, November 6th. The Tap and Jab will be provided for the picture. Sign up outside of room 208 and bring $25 on picture day.
Y'all,
If you're interested in boys or girls bowling, please take that collection in room
keep your
406
sheet out.
or Tech
Trust
Patton
me.
Library. Have a marvelous Monday and be with God.
Number 5 is the most important question on here. An isometry is a transformation that produces an image that is congruent to the pre-image. Is the transformation of an object using dilations in isometry? No. You have got to recognize this. Does anyone know what we would say that the images are? They're not congruent, but there's an S word that was in the objective.
Similar.
Okay, the images are similar, not congruent. We'll talk more about what it means to be similar tomorrow. Make sure you have number 5 down. Those images are not congruent, but they are in fact similar.
We're gonna have to build that. You're gay.
Please note.
Listen before we fight.
Is that a threat?
That's a big heaven gate.
Not the big heavy gate. Don't spend long riding.
Now you're going to hell, you checking the
Ladies and gentlemen, before you leave, just leave it on that table. I have 5 pages that you can hold on to. This is your review for the test that we have coming up.
Show me, you was 5. That's what
Double stuff.
Alicia, I got it. Did you really just steal that from me? Hold on, man. It's been way too long this time.